Hello guys, welcome to the channel. Today we will be solving this LeetCode problem of the day. Today is 24th February 2026. So let's get started. So the problem is tagged as easy and it's really easy. So let's start. So we are given a root of a binary tree where each node is either 1 or 0, and we have to find sum of all the numbers that can be formed by representing this number from root to left as binary of the numbers. And for example, this tree is given, and what are its leaves, right? The root to leaf paths are 100, so which converts to 4, then 101, which converts to 5, then 110, which converts to 6, and 111, which converts to 7. Okay, so this is a backtracking problem, I will say. So I guess no explanation is needed. It's just pure implementation. Let's get started. So we have a root we will pass the root, and let's take a string which will contain the binary binary of the number, and which will be backtracked. So initially it will be empty. So let's pass it over here. Now we want to define a function. So I'm defining a lambda function here. So let's say return type will be void. Will uh, it will get a tree node star, then a string referenced. The tree node star will be our root, and string will be it will return nothing. That means void. Now what? Now if you see, when should we stop, right? Uh, so the answer is that we are gonna write some recursion, right? So during recursion, when we reach at the leaf node, so what is the definition of leaf node? The left part of it and the right part of it is null. So what I can say that if roots left is equal to null and roots right is also null, then this is a leaf node, right? This is a leaf node, and then whatever we string we got, so convert the binary string to integer. So let's say that, okay, let me take this image, uh see if I get it. Okay, let's like this. We have 100, let's say. This is just an example, then 110. Now if you see, uh at this point, as this is a leaf node, we should have a string like 100. At this point, we will have a string like 1110. Okay. Now that we have the string, we just have to convert it to decimal. So how will you convert that? So the implementation will be like this. So basically, let's say we have a binary string, something like this. Okay. Let's mark the indices from right to left, as I discussed in previous videos. Like in binary representation, the indexing starts from right to left, and if we will check if it is a set bit or not. Basically, s of I should be 0, I mean 1. Okay, if this is it, then we can add this power to our number. I mean, so we want to form the number, right? So initially the num will be initialized to 0, and if let's say this is a set bit, we will add 2 raised to 1 to it. Let's say if this is set, as this is set, we will add 2 raised to 3 to it. Okay, and that's it. Let's implement that. Let me go here. Basically, when we are at leaf node, we will already have the binary string. We just have to convert it into decimal form. So let's take in equal to 0, then a less than s dot length a plus plus. Now we just have to check if this bit is set or not. So how would you check that? We just have to check like this. Okay, so uh, it's in the the indexing of string will be different from indexing of this thing. Okay, this is where my j is actually looping from this to this, but for this 0 I want to access this one, right? So basically it's n minus 1. So basically s dot length minus 1. Okay, let's call it n minus 1. And what about 1? This one will be responsible, so its index is n minus 2. What about 2? N minus uh, basically this will be, yeah, this will be 2, this will be n minus 3. So what is the formula for this? So it will be n minus I minus 1, basically j minus 1. Let's implement it. Let me call it as a start line. Just put n over here, n minus j minus 1. Okay. Now we just have to check if so no wait. I guess this should be there, and we just have to check if n minus j minus 1 is a set bit. If yes, we just have to add power of 2 raised to j to that, and finally we have the num over here. So have the number. Now what we want to find the sum, right? So just take a sum, then add it to the sum plus equals to num, and finally return it. Now this is a recursion, just pass roots left as roots right as, but before that we have to push the current element. So what will be the current element that will be pushed is roots val plus 0, converting it to the character and pushing at the back of the string s, and finally backtracking it. So just pop back it and finally return it. Now there is also one case where this root can be null itself. So as you can, okay, we are not given a tree like that, but you can imagine that, let's say you will have some tree like this, basically one, and let's say there is nothing on the right. So in that case, what you want to return, you just want to return 0 over here. Okay, so you just want to return from there. So if, if root is null, just return from here. Finally, just return some. Dang it, we are getting some error. So let's debug it. Let's see. Okay. One thing we forgot, that when we are at a node which is a leaf node, we should also push back its value. So we will do this thing here too. And also at the end, you should pop back it. Now let's see if it's working. Okay, let's try to debug it. Let's print S. Let's see what binaries we are getting. So as you can see, we are getting 100, 101, double 10, and triple one. That is fine. So why it's not getting added? That's the question over here. So s dot length, then n minus j minus 1. Should I, okay, I forgot. It should be num plus equals to. That was a small mistake there. Uh, yeah, it should be working fine now. Okay, I hope you got the answer. Thank you so much for watching.